All right. Yay, we're live.
A little too soon. And now, yeah, it was slow to kick off. I'm like, dang it.
It's fine. Everything's fine. You still do the little go live thing better than I did it the one time I suffered through it without you. So,
No, you were great. You were great, Hilliary.
we were just joking about the fact that I pretend like I can't do this stream without Johnny's administrative skills. But I can. I just don't like to. Right. So, good morning, GitOpsians, or for Natan, it's very evening for you.
Yeah.
So thank you for joining us. Quick announcements in terms of GitOpsy things. I don't think I have any announcements. Johnny, am I forgetting something?
No, just KubeCon's coming up next month.
KubeCon's coming up next month.
November. Yeah, it's almost next month.
2 months. What even day is it? I will not be there. We talked about this a couple streams ago. My kid's birthday is right in the middle of KubeCon North America. I will be staying home with my kid. However, there's a very good chance that they will be giving out copies of my book that I wrote with Andy and Max at the Dynatrace booth. We are officially done writing it, and It's available for pre-order on Amazon, which is really exciting. So yeah, if you are going to KubeCon North America, stop by the Dynatrace booth. I think they're actually signing the books too. So then you just have to like track me down with your other previously signed book, like a Pokemon. I've got to catch them all.
Nice. Hey, congratulations. That's awesome. Because I know that's a lot of work, and it's
oh
nice
my god,
to be done.
It was so much work. However much work I thought it was going to be, it was way more. Speaking about,
what's the title of the book?
The title of the book is called Platform Engineering for Architects, and we published through Pact. And
I saw this on LinkedIn.
Yes, I did post about it on LinkedIn. And yeah, like I said, it's available for pre-order. If you pre-order, awesome. If you hold out for your free copy from Dynatrace, also awesome. I'm not particular. I'm just really excited that it's a thing that we did.
That's awesome.
So, other than that, like I said, no announcements. We're starting to look forward to future conferences, I'm sure. I'll keep people, aware of the situations for CFPs and so forth as those come up. But in the meantime, let's get to today's actual topic, which I'm excited about because I have kind of been tuning out the AI stuff just due to being very busy and not due to being just very busy. And so Natan, introduce yourself. I know you've been on the stream before, but as somebody brought it to my attention, I've been doing this for 2 years. So that may well have been near 2 years ago now.
Something like that, yeah.
Yeah.
So I'm Natan from Robusta, and we do AI analysis of Prometheus alerts in Kubernetes and OpenShift issues. And we have an open source project that does that as well. And it's interesting. It's been a really interesting journey on this because we started off and went really fast, like a year and a half ago, from a place where like, oh, this is interesting, let's play with it, and that will never work, into a place where like, oh, people are actually running this in production, and this is really useful. So that's been a really, really interesting journey. And like, as a little bit more history, like we started with, we have another 2 open source projects, another 3 actually now. One is called Robusta, and we take Prometheus alerts. Then we originally built that on like an older kind of technology with runbook automation. So we take alerts and then let you automatically remediate those for polling context. And we ended up discovering along the way that also like the AI and LLMs can actually do a lot of that more broadly and even better than some of the handwritten like runbooks. And then we also have a project called KRR, Kubernetes Resource Recommender, that a lot of people know, for getting suggestions on your Kubernetes requests and limits based on historical Prometheus data. And then we took over KubeWatch from, I think, Bitnami, that got acquired by VMware, and then the project got kind of thrown out. So I guess we do a lot now. I stopped and think about it. But we do a lot in the open source world. We love Kubernetes. We love OpenShift. I'm an engineer by background, and I guess it's been a really long introduction, so I'll shut up.
Oh, yeah. When you were on here a couple of years ago, we talked about that. Like, people should go back and rewatch that episode. It was a great episode. I'm sure Robusta has changed quite a bit since we took that initial look at it. But the part about the episode that's worth watching was when I had asked you about like, okay, tell me what that's like deciding like, I don't remember how I asked, but roughly like deciding 30 years after Red Hat decided to be an open source company, like what made you led you to make like the same decisions. And I know you answered it there. So if you want to answer it again now with an additional 2 years worth of like experience on your belt, like please do, because I think for me that consistently becomes my favorite thing, is just seeing other companies following this model and championing that like you can be a company and you can also be an open source software contributor. Like both things are true.
Yeah. So Red Hat, by the way, is a really interesting story because the Red Hat model, I think, has never been replicated like at Red Hat scale. The Red Hat model was originally support based, and I don't think that model has like ever been replicated other than Red Hat at that level of success. And if you look at most of the other open source companies out there or source available companies, right, and a lot of them have now do like the open core model, or they do they offer managed service, and then they have like an open source that you can run yourself. So we ended up choosing more of an open core and like a managed offering. That made sense for us. But the main reasons for it was that we thought, and based on how we as engineers adopted software, like all the software that we went off and we paid for was based on stuff that we had started. We had tried it because it was open source. We liked it. We were able to contribute back. We had transparency into what it was doing. And we thought that was just a model that made a lot of sense in terms of getting out to people who don't want to go through like a big bureaucratic process and book a demo and speak to someone. And like you're often not at a point in the organization where you even can sign to get something like that in or know how to advance that process. But you can still go off and try and evaluate new stuff that's open source. And that was a big part of our motivation for doing that. And I'm curious how that compares to what I said 2 years ago. So I actually don't remember what I said then.
It's like the complete opposite.
Yeah, right. Probably. I don't know. Well, we could always splice those clips together back to back and see. I actually do feel like your answer was really similar at the time. But anyway, so moving on a little bit past the reminiscing into the today. Today you're going to show us HolmesGPT, which I actually didn't even Google it. I was like, all right, I'm going to do nothing. I'm going to go into this very cold. So explain to me like I'm 5.
So maybe I'll start from the motivation, if that's okay. Before I speak about the solution and attack, and like let's speak about the problems that people have and like why you would even want to do anything like this. So let me share my screen, and I'm going to just go over here. Tell me when it's up.
There it goes. I enabled it now.
So I imagine we've all seen this, right?
I would hope so. Yeah.
If not, you're on the wrong podcast. Oh no, maybe we have Kubernetes people here, so that's okay. This is the OpenShift console, and I'm looking at the Prometheus alerts that are firing in my cluster, and you can see this in many different views. Some people may be like more familiar with a view of this in Slack, like here's a firing Prometheus alert, right? People may be familiar with this in like many different contexts, but the gist of it is, a lot of us have alerts that are coming into our system. And I mean, almost everyone who's running real production has alerts that you have to look at and respond to. And very often these alerts lack a lot of information. And I'll just give you an example. Like if I go into this cube job failed, right? I have here a Kubernetes job that ran and it failed. And like, should I care about this? Like, does this matter? I'm getting this alert. Like, presumably someone set this up. I'm looking at this, right? This is one of the default alerts. Is this an issue that can actually cause downtime and cause a business impact to my customers? Is this an impact that I should, like, this is a proactive warning and I should take action on this and understand this and go ahead and fix this before we start getting customer complaints, like later in the day or tomorrow, before like maybe this is hiding a bigger underlying issue? Or is this just a false positive and I can move on, right? And I don't need to pay any attention to this. And in large production environments, then very often there's like a very large scale of alerts. And kind of the obvious question is, well, can we do a better job at this? And especially now with AI? Like, are there ways that we can actually use that to turn this into something that's really clear and actionable and like shows me exactly what the impact is and why you should do about that? And the reason why this all matters, like you can look at it from a few different perspectives. From like if you ask your boss or your boss's boss or boss's boss's boss, right? What do you care about? Well, you care about not losing customers, right? So you care about customer satisfaction. You care about not having downtime. You care about not having like a widely publicized incident where everything is down and you're not serving your customers, right? Think about what happened recently with CrowdStrike. Beyond just not serving your customers. If you look at it not from like the business perspective, right, but if you look at it just from like a team perspective, well, if your team like didn't have to spend a certain amount of your time looking through this, right, then you could presumably spend more time actually like writing code and developing, and that's in dealing with on-call duties. And if you look at it from kind of more of an organizational structure, right, in many organizations, you have either platform teams or customer success teams or DevOps teams. The model often is different, but you have people who are more familiar with dealing with some of the Kubernetes or OpenShift issues than others, and they have that expertise. And then you have other people and developers who are sometimes getting these alerts, who are dealing with these issues, and they want to be able to go and to solve those faster, right? And sometimes when they get those issues, then they're open to take it or they'll speak to someone on the platform team or the customer success team or the DevOps team, right? And then that team ends up spending a lot of time supporting them. Well, like, wouldn't it be great if those developers could actually do more on their own? And maybe they don't always have the right expertise, but could we like make it easier to get an answer without us than to even go off and ask the person who has the expertise? So can we share that knowledge within the organization more efficiently? So these are all different perspectives, but they're all coming down to the same technical problem, which is, can we take an alert like this and then like automatically provide more information about that and maybe even show some hints on why that's occurring?
I mean, this is very relatable for me, right? The job that I do and where I sit in the Red Hat organization, this is very, very relatable. So 100% makes sense.
Yeah, this reminds me of like the conversation that we always have, Hilliary, or like, you know, basically anybody that talks about like SRE or anything like that, where it's like, how do I at 3 o'clock in the morning figure out what's important and what's not? Like, how do I get through all the crap and that where's the things that I need to focus on instead of coming in, looking at this crazy dashboard, looking at all this other stuff that's going on and then trying to figure it out, to have something that's like, hey, here's what's blown up. You know, maybe this is what you should, you know, look at or whatever. Read this.
It's like what Christian and I were talking about the other day when we were talking about monitoring Argo CD or Argo CD observability, right? There's a difference between data and information.
Yes.
And so, and then to further your point, Johnny, it's funny. I just gave for my DEI community that I have been running for also 2 years. I've been running the stream for 2 years. I've been running the DEI community for 2 years. And just gave earlier this week a webinar with one of my co-leads, and we were talking about like, here's how to approach debugging. And so for debugging in production, which was the section of the presentation that I gave, the very first thing I said was control the panic, filter the noise. Right? Yes. Control the panic, filter the noise. This is number one step when you're trying to figure out how bad is something, how wrong is this. Control the panic, filter the noise. And those two things are related, because if you get a ton of data that is not information, then that's going to feed into your stress, right? So
yes,
really, it's so important for getting people through things. And the self-service aspect of this is really important, because you can't always be waiting on somebody's, you know, time to get to you, right? If you have a platform engineering team and you're a developer and you need to open a ticket with them, even if they have a 15-minute SLA, that's 15 minutes of what are you doing during that time, right? Like, maybe you're still poking around at it, but you're not making any progress. You're losing kind of the flow state, the mental, like place that you were for the thing you're trying to do. Sometimes by the time you get through one of these back and forths, it usually is like, I'd say it's a minimum of an hour, honestly. By the time you have to open a ticket with somebody, you're looking at a minimum of an hour before that situation is resolved. Okay, well, now you've lost an hour of productivity. You've lost, you know, your brain has gone through all of the things that are not the thing you were trying to do. Like, there's a cascade effect on productivity when you have to completely break your workflow. So the concept you're talking about is like bringing the troubleshooting to where the person is already working, like bringing it to allowing it to integrate more into their workflow, or being a little bit less disruptive. I would be willing to work with a flawed tool for some time while it trains and gets better for those ultimate gains in productivity and the fewer amounts of context shifting, because just shifting back and forth between the system and the ticketing system is not mentally fun. I don't know how it is for everybody else. I'd be curious to see if anybody's like, yeah, I have no problems with that context shift. I'm somebody who context shifts very well, and I still find that immensely aggravating.
Yeah, so one of the interesting things is you actually, like you were speaking there about ticketing systems. So depending on who is looking at the problem, the main difference, like in what people will care about, always turns out to be the integrations, which is really interesting. Like you could have, like everyone could have the same kind of core problem around the business, right? Like, or we have these alerts and like we care about solving that. But then this takes many, many different flavors from like we're a platform engineering team. We have a large load of tickets from developers. And we want to reduce the number of tickets from them to, and then the integrations like aspect of that, right, becomes we should integrate now with like ServiceNow, and we should integrate with these systems, or more of an SRE and like reliability angle, in which case like we want to reduce the mean time to response. Then you're looking at integrating with PagerDuty, to more of the developer angle, right, and like developer experience and kind of platform engineering angle as well from the dev side. And then you want to integrate like with the tools that the devs use in Slack and so on. But you end up taking like the same core problem. There's an alert firing, and I don't know how to fix it immediately, or that's missing information. And then that has many, many different angles, like depending on who is looking at that. But the core area that the angles are different actually is always the integrations.
Yeah, it's really about meeting people where they are.
Yes. But okay, so this is the problem, right? And traditionally, what people have done is they've added a link here that no one ever reads. So, and it turns out that this link here that no one ever reads on what you should do. Well, first of all, it's a little bit flawed, because like I have an issue, I'm under pressure. Maybe I have like 10 or 20 alerts that are suddenly firing in a storm, and like I don't have any time. I'm trying to figure out fast, and now you're expecting me to go off and read a page, right? So that kind of like is more burden on what I now have to do, and I have to understand everything that's written here and so on. But the other challenge to this is like, okay, well, this has like a bunch of instructions on what I should go off and do, right? And how I would troubleshoot. I would run this command, I would see this, if this, then that, right? So there's kind of a troubleshooting tree here on what I should do. Like, well, why not just go and do that, right? And then give me the answers in the bottom line. And traditionally, like to do that, then you'd use runbook automation, right? And you set up a complicated flow to do that. It was just a big investment. And then when you look at that from like the perspective of a single alert, and like the question becomes like, okay, how much effort would it be to add these runbooks for all of our alerts? And that's important work, but it typically gets deferred, and like then you end up adding them, and people don't always go out and look at them again. And this is where it becomes really interesting to look at that AI angle, because AI does a decent job following instructions, right? And like doing exactly what you tell it to do, assuming it has access to the right data.
I mean, that is the key assumption there, but yeah.
So let's start with what, like the obvious thing that won't work, okay? Like let's just take this entire page and let's go over to ChatGPT. And this is so dumb. Like it won't work in so many ways, but it's illustrated for why it doesn't work, right? So like, let's go over to ChatGPT and let's just say, why is this alert firing, right? And it's poorly formatted, but it'll figure it out. Or it won't figure it out, but like for that problem, that part won't block it. And I'm essentially getting back like kind of a decent summary of like what the other is actually saying, more written in English, right? So it's fine because this Kubernetes job has failed to complete, right? Well, yeah, that's true. It's writing in a lot of words, kind of what is already there. And it's giving me actually these suggested actions, right? And these suggested actions are kind of the commands I could go and run to troubleshoot. And this is kind of like what was there in that run book. Just this is telling me OC get pod, right? And then This is giving me commands in kubectl. Okay, fine, right? But it's telling me go and look at the logs, right? And understand why it's failing, and like run scribe on that and check. And then based on the results of that, you would do different things, right? So the question is like, well, what I'm getting here isn't so useful because like, again, really what I want to do is like, well, go do that, right? Like, don't just tell me fetch the logs, like go fetch the logs. And of course, OpenAI doesn't have access to my cluster to do any of those things. So what Holmes is at its essence is it's essentially a wrapper around large language models like OpenAI and others, AWS Bedrock, Azure, even a little bit of support for Llama. And what it does is essentially feeds in an alert like this, and then we ask the large language model, like, what commands should we run? And we give it like kind of a list of templates that it's allowed to suggest. So for security reasons, they can't go off and run any command. They can run a like preset defined list of commands. And we say, which of these should we run? And then you go and you run those commands. Then you take the result and say, okay, I ran that. Here's the result. What command should I run next? And you do that iteratively. And you end up getting really interesting results and like pretty valuable results because the AI is able to actually then go and look at the issue and investigate it.
So is it, yeah, right. So is it running, it's running on the cluster somewhere, right?
Running on the cluster, yeah. Well, it's running either local. I'll demo today two things. I'll show you kind of in our web platform, like how it looks when you're running it with a UI and it's running in cluster and so on.
Mm-hmm.
And then I'll mostly focus on the CLI, which is the pure open source version. And there I'm just running it locally on my machine.
Oh, okay. That makes sense though, because if you have the ability to log in from your machine, it can act as a person, a user. So it gets its own, like, when it's running locally on your machine, is it impersonating you, or does it have its own token and RBAC?
It's using whatever kubectl context I've chosen to give it.
Okay.
Or OC context. And really, I should say, like the core idea here, though, is actually not Kubernetes or OpenShift specific. Like the only part in anything that, like if you think about what we've described so far, right? Take up Prometheus alert, feed it in, say what commands should I run from a list of pre-approved commands, right? Run those, feed it back in. Like the only part of that that's specific to Kubernetes is the list of pre-approved commands. But when you want to say, like, let's say you say, okay, go investigate a CloudWatch alert for an EC2 instance, it's actually the exact same flow. You're just going to give it a slightly different list of pre-approved commands that it can use to investigate EC2 problems, right?
Awesome. Well, I don't have any other like leading questions. So if you want to jump into these demos.
Okay, yeah. So let's start with an example, and then very soon we'll go over to the CLI.
Sure. Can you actually just make your screen, since this is not a super familiar screen, it's a little small. Can you zoom a little bit?
Is that better?
That looks fine for me. I'm sure the audience will tell us if it's not.
I worry about zooming in a little bit too much that it won't be formatted right. But yeah, if this is too small for someone, like please also just leave a comment.
Yeah, I think that looks fine. It's definitely legible to me.
Okay, so like let's start, and maybe I'll take here. I'm just looking at a trend of alerts over time, right? And maybe we'll slice that by like the application. Okay, and let's take here like an alert here from this Java API checker, and I have here again a Prometheus alert, kube job failed, same exact alert as before. And if I go over here and I just click on the root cause, like, well, why did this job fail? It reached the back off limit database connection issues. So this Java API checker in namespace default, it failed. It had repeated database connections. It tried to do these connections multiple times, couldn't connect to this database. I have here the database, of course. And then eventually the job failed and it backed off. And you might be thinking, well, okay, yeah, like how does it know that? So of course I can like drill down into the details here, right? And I can see here like exactly what commands it ran to go off and to determine that, and then see the output from each of those commands and so on.
Nice. Okay, that's very helpful. And And so it has, you said it has a list of pre-approved commands, right? So does it map those like based on alert type? Does it map is there any mapping at all? Or is it just, no, I can do all of these things and then it has a decision tree it makes? Like, what is the level of like manual tuning on what it does?
So that's the really cool part. And that's the part that excites me the most. And that's the part where like I think we're the most different than other stuff that's out there, like K8s GPT, for example.
Mm-hmm.
A lot of the like tools that came out early on, they would essentially do a human mapping and then feed the data into an LLM for summarization. So you would like take another, you look at certain labels based on those labels, and you run certain kubectl commands that you have like predefined. But again, then you're kind of you're using an LLM, but you're very much using it the way that you would. You're very much using it the way that you would have done runbook automation like 10 years ago, right?
Mm-hmm.
So I'll show you how it looks in the core idea. The core idea is let me build that up more. Here's a command. Here's how you run kubectl describe. So we have a name, right? That's just an identifier. There's a description. The LLM uses the description to decide when it should go off and invoke this command. When is it relevant? And then this is just templated. Mm-hmm. And I can template this anyway. I call this kind or Kubernetes kind. I can call it whatever I want because that doesn't correspond to any label in the alert. It doesn't correspond to anything in there. And what's cool about this is the LLM actually knows it sees the parameters that are available here, and then it figures out how to extract the right parameters from the alert, and then automatically fill in the right parameters here and run this command.
That's fun. I like that. So it really is just making decisions based off of it's turning data into information, essentially. It's making decisions based off of all of those little pieces of metadata that exist in alert that for us, we probably interpret without even thinking about it, right? I'm getting some kind of issue. I run a command based off of intuition. You know what? Sometimes I don't even know why I run certain commands, but it typically works. So it's kind of doing the same thing.
Yeah. So there's actually live knowledge within teams even for what commands you would go off and run. Like one of the early adopters of Holmes is a big Fortune 500 organization that uses a service mesh, and they have knowledge within their SRE team when you have an application issue related to HTTP errors. Like this alert will fire, and the first thing you do is you fetch the logs from the service mesh and you do a grep on the logs for the name of the pod, right? That's like the first thing you always do. So one of the things that we built for them that we baked in then is the ability to go here and to give instructions. So you could say when this alert fires, like, fetch logs from linker D, from the linker D pod. First look for pods in the cluster with linker D in the name, and grep for the name of the endpoint that is failing, right? And then I can go and I could just run something and it would follow those instructions. And again, I don't have to specify even how to do that plumbing and how to hook up the different components. As long as it has the right tools to do so, then it can go off and it can do that sort of plumbing.
In a lot of ways, it feels like the thing that you're doing when you're walking somebody who's got plenty of experience, but isn't experienced on your system, like through something during their onboarding.
Yeah, a good mental model for large language models, I think, is like a really junior engineer who is the most hardworking person in the world. And they will do, if you sit with them and you explain to them how to do things and you invest in them, they will be really good and they will work harder than everyone else. And they don't mind waking up in the middle of the night and doing long hours. But you have to give them instruction and guidance on what to do.
Yeah. Because I was like, the way you just described it to the LLM, I was like, that's pretty much exactly how I would tell somebody onboarding or a junior engineer. Like, I expect you know the commands because that's rudimentary, but now I'm going to give you, a high level list of them. So that's fun. That's neat.
And then one of the other things, sorry, go ahead, Johnny.
Oh, okay. Thank you. Yeah, I was just going to ask, do you have any of these where they actually take an action, or is it all like just go and get information, go and describe something and pull that stuff back, parse it, and then redisplay it? Like, do you ever have something that says like, hey, if this pod in this namespace is doing this with this name, it's okay to restart the pod until, unless you've done it 3 times. You know what I mean? I don't know. I'm just throwing stuff out there, but like, do you ever have it to where you can actually do anything? Because it looked like all your logic was like get and describe, that type of stuff.
Yeah, so we're playing with, so we don't do automatic remediation with the LLM. It's technically doable.
Mm-hmm.
We want to, I don't think we're at a point where like our users yet want to do that. So, I think we will get there, especially as people build up more and more confidence. And if you can do certain pre-approved things, we're experimenting like around what you're saying. We're experimenting with different output formats though, that also provide more or less recommendations, or like more verbose or less verbose. Like this is kind of what we would consider to be concise results. But if I go over, maybe I can take as an example. Let me take here a different example from like a job that failed. Let me see.
I was gonna say, from the perspective
Yeah.
of right actions, Johnny, right? Right actions, even and just like restarting a pod is a right action. Right actions are kind of like closely guarded.
Oh yeah.
It's one of those, whether the LLM can do it without high risk or anything like that is.
There are people doing it at scale.
Yeah.
There's a specific company that I can't name, but that we all know that does like LLM based remediation at scale. I think they have some safeguards around it, but like, and they think they'll get to something like 80% coverage of all the production issues in a few years.
Yeah. A lot of them are very safe actions, right? A lot of them are very safe actions. But it's like there can be sometimes where if the thing most people doing anything at scale will have the correct built-ins, they'll have the correct RBAC. They'll probably have the LLM running with a service account that has the RBAC required to, not exceed its what's known as safe parameters. They'll probably not allow it to touch certain namespaces. But a lot of that requires a degree of sophistication in your own ops where a human would be able to execute that so perfectly.
And maturity and all that, right?
Yeah, it's really like your AI is only going to be able to be as mature as your team. And we talked about this when you were here and showing the ML ops 2 years ago, Natan, right? Somebody asked about that, about exactly kind of this thing, like, well, can the ML do the thing? And it's sort of like, you can't expect your AI, your ML, your whatever to be able to exceed your team's capabilities, right? It's only can ever be as capable as your team. So if you know what this stuff means when you look at it, if you know how to do the things, then you can train your AI to do the things. You can tune your machine learning to understand, make the same decisions that your very experienced engineers would make. But sometimes for me, what I see quite a bit is sometimes like, this is a really good example. Cube job failed. This job is failing because there's a problem with the database, right? Or there's a problem talking to the database. So now the next like series of investigations, like, okay, well, is the database up and healthy? And then is the database, is the networking between the job and the database correctly configured? Like that would be like kind of the order I would do things in. You could also do it in the other order as well. But I don't want an LLM to just go and decide to restart my database so that, it doesn't have too many connections.
Like you want an LLM to go in to read the logs on the failing job, say it's the database, then to go to the database and to like say, oh, the database actually has high CPU, and then to say which query is causing high CPU, right?
Yeah, but I don't want it to touch it because it doesn't have the context to know, oh, if I turn this off, I break everything, right? Like it doesn't have understandings of context around workloads and their importance and what is considered safe and not within the series of dependencies that exist in a system. So that's where the hesitancy for write actions comes in. And again, you can namespace kinds, you can restrict its access for write actions all the way down to what you exactly know is safe. But you're not gonna be able to teach it to know anything that your team doesn't know or somebody who's training it on your team doesn't know.
Yeah. So okay. So I'm with you on the. What's interesting here is I think I'm with you on the remediation aspect, right? And I think we're not yet at a place where most people want to do that sort of automated remediation. We yet have enough confidence to do it.
Yeah.
But the interesting thing that kind of touches on what you're saying is actually about bringing in the knowledge, and like if you already have those pages in Confluence, right? Like why not feed that in?
You absolutely can. Yeah, that's what I mean. Like
that context.
It's and again, as long as you put up the correct safety rails, like it should, if you have if you have the architecture diagrams, right? If you could describe an architecture diagram in words, you could give that description to the LLM and have it understand the layout of the system. And so then it could start going through, it would know not just to go check the database, but to also check the networking layer for, inner communication, right? All those things, and all of those are read actions. All of those reads, all of those describes, and any sort of read action, I think those are very safe. Let it do them all. But well, I mean, okay, they're very safe within reason. Maybe don't have it go open the database and do select star, but you know what I mean, right? Those are very, very safe.
Containers. Ephemeral containers are interesting. When I was playing around earlier with giving access to run ephemeral containers for networking issues. So like the ability to go and run an ephemeral container and then do curl or ping from inside the pod. That's just kubectl debug, right?
Yeah.
But what's interesting, so that's actually kind of read only, but with some potential side effects, right? Again, limited, but there are things that push the boundary a little bit.
Yeah, that's true. And if you're already having scheduling issues, then trying to get a debugging pod, like, that may get stuck. That may not work so well. So I think there's a lot of things that it could do that are like very, very safe in terms of write. Obviously, most read actions, very, very safe, very well, like very advisable to let it do, because we have some automation that runs and gathers a bunch of information and context for us when we get an alert. And it's important to know that sometimes the LLM's interpretation of things, when you get into like a little bit more like levels of complexity, it's not accurate, right? It doesn't accurately interpret or accurately represent what's going on. What it does do a really good job of, though, is it actually does pull out keywords really well. So if I'm reading something and I'm like, that doesn't make sense, but I'll see a keyword for it in its description, right? So then I can go find where it got that keyword. Either it may have come from somebody else's comment somewhere, or it may have come from a log somewhere. It'll help me to find the thing that will tell me what's really going on, even if the LLM is not correctly interpreting or correctly representing it. It does a good enough job at identifying what's important that as a human, I read through its summaries and I go, that logically doesn't make sense. What it just described is impossible. But the things it described, okay, those all definitely could be at play for this issue. I'm going to go see what's actually really happening with them. And I'm going to go look at the logs it gathered. And I'm going to go look at the metrics it pulled in. And then I can actually get to like a real answer based on that. So it still reduces my cognitive load, even when it's wrong, by helping to have like already taken care of some of the important grunt work of solving the issue for me.
So that's an area where we're really, really split on internally, is how much we actually want to push to get the root cause, so to speak, and how much we want to push to just kind of show the steps that have been taken. So I found the example I was looking for. Let me put that up on screen. Here's an example of like an alternative display format that we're playing with a little bit, right? Where instead of going up and saying explicitly like, okay, here was what we think is the root cause, to say like, okay, here's the alert, right? This is an explanation just based on the data in the alert, right? Like we're not making any logical conclusions here. Here's an investigation. These are just facts, like what we went off and checked, right? Like what do we know? The job failed with this, the pod is in terminating state, the logs indicate connection reset error. Like these are all facts that we know that are grounded in the data that was gathered, right? With very little room for hallucination here, or very little room for like going down the wrong logical path. And then conclusions and possible root causes, like, okay, this is speculative, right? Like connection reset, the pod did encounter connection reset and that caused the job to fail, right? There might be a misconfiguration issue with the Prometheus connection, or there could be a transient network issue, right? But like this is the area that's a little bit more speculative. And then again, next steps, that would also be speculative, right? And I'd actually love to hear both of your takes on this. Like how much does it make sense to go off and say like, okay, here's the conclusion versus, and the conclusion very often will be correct versus, okay, here's kind of what we went, here's what we know for a fact, here's what we went off and we gathered, and then here's some speculation around what that root cause could be.
So this is it has some contextual differences between this and the AI that I'm leveraging, because the AI that I'm leveraging it's actually integrated into our ticketing system. So it actually doesn't just get all of this data, but it doesn't actually provide next steps. It would do something similar to the conclusions part. But it also will see what people when we're doing something, especially anything that's really complicated and it gets handed over from follows the sun. Most things don't, but every now and again something comes up, and it's always some weird, bizarre niche thing that you're like, okay, well today I learned, or it's something really dumb. It's just, there's like no middle ground. It's either like crazy, bizarre, niche, or really, really dumb. That's it. It's 50-50. And so people will leave comments. Here's what I tried. Here's what I saw. Here's what might be relevant. And so it's interpreting not just data, like raw metric data, but it's also interpreting human input as well.
Yes.
And that's where there becomes room for hallucination. That is like a greater degree than what you're going to see here, because this is not also interpreting what people are saying about the issue, or what people are saying about like.
So there are similar so there actually are similar complexities. I'll tell you an area where we got wrong initially, but like it's easier to fix with more fine tuning and like with more adjusting, is having the LM differentiate between this pod failed because there was a permission issue, and this pod failed, and when I went off to investigate, I wasn't able to investigate because there's a permission issue like with the service account that I'm using right now. So those two we would see a lot of mix-ups on initially. Like we would say, oh, the pod failed because of a service, like a permission issue, and like, no, the pod didn't fail because of a permission issue. You just failed to run kubectl or OC and investigate because of a permission issue. But that sort of thing is often just tractable to making sure that in like what you're feeding in, prompting, or like fine tuning on, or what have you, that in that sort of thing that just is represented.
So
yeah.
So real quick, can you guys
funny.
explain? I know what the term means, but that just for the people that are watching. When you say hallucination, right? And we're not talking about like, okay, I was gonna make a really bad example, but we're not talking about like fun hallucinations. We're talking about like technology hallucinations and like the software that you're using, right? So
Well, they could be fun.
I mean,
they could be entertaining.
I've been watching too much JRE, so like it was just gonna get bad. So
a hallucination. Okay, so a hallucination, which are less and less common, but especially in earlier versions of ChatGPT, if you would say like, why did X, Y, Z happen, and it would give you an answer that was not based on any data. So like we would contrast that with, maybe I'll even manage over here, like it usually is about the LLM misinterpreting its role, right? Like, like you're, you got this alert, say Wyatt fired. You're not allowed to gather any extra information or ask questions. You must give an answer.
What is this, Saw?
Wait, I'll explain why though. Why I'm doing this, and again about that. I'll explain in a moment why this sort of prompt also makes sense.
I just the parameters behind it. Sorry, I just was like, this is just like a Saw challenge.
Yeah. So this actually didn't hallucinate here, right? This is telling me an answer that is based on what was right up over here. But the reason, maybe to make it more clear why hallucinations are, it's worth looking at like what is the core technology in LLMs. This is inaccurate in many ways, but as a first pass, right, a first level approximation, the core technology of LLMs is that it is essentially auto completion on text. So you write a sentence like, hello, my name is, and then you essentially feed that into like a neural network. Again, transformer based, whatever, not precise in any way, but you essentially feed that into in machine learning model, as we once called them, and you say, what is the like most likely next word over here, right? Based on your training data. And this was trained on the internet, so it read everything else online, and then it essentially gets back an answer saying, like, this is the core of how, and this really is the core of how, like, OpenAI and all, like, ChatGPT and all these things work. The core of this is essentially taking a sentence like this and then saying, what is statistically the, like, most likely next word here? And, like, the answer then, based on everything on the internet or whatever, would be like, I don't know, Bob, right? So then it outputs Bob. And then the big question is, how can you like take, like, how did this auto completion turn into this with me asking questions, right? And there's a lot of magic that went behind that. But essentially, what OpenAI did is they did what's called fine tuning and like in various other methods and reinforcement learning and stuff. And essentially, what they did is they gave it now not just the entire internet to train on, but they gave it like think of thousands or millions of sets of questions and answers, and they like you could think of it as like you kind of reward the model to teach it what kind of behavior to encourage. So it's not just what is statistically more likely, but what is a kind of what was it trained on to give answers for. But the gist of it is that you give the model a bunch of, when you're training, you give it all these questions and answers, and then you get it to realize that it's not, you train it so that when it auto completes, it's auto completing what is a likely answer for ChatGPT. So when I type something here like, what is your name? Then ChatGPT was actually trained on that. But the most likely auto completion is like, hi, I'm an OpenAI model, right?
Yeah.
So hello, I'm Skynet. Yeah.
Yeah, right. There we go.
Exactly.
I was gonna say the way one of my colleagues gave a really great I don't even know how long ago this was, several months ago now. He gave a really great like example of how this works. And like when you say the statistic likelihood, some models have more like it's all like it'll be like only allowed to give you what it thinks is like 90% likely, or 80% likely or more. And then some of them will be like, if you want to see a hallucination, you actually allow it to have a greater variance in statistical likelihood and for what it's allowed to supply. So it'll say, anything you have 60% confidence in more, you're going to start seeing some very silly responses from your LLM, right? And then with the like the way the feedback loop goes, it adds a weighting onto things. So you have the statistical likelihood, and then you have like, I think the way it works is like an additional weight applied. So it'll say if we've got something of like two things of like equal statistic likelihood, right? Let's say Bob and Fred. I don't know. Fred seems like a very common name too. Like, okay, Bob and Fred, right? But people have told it Bob is better. Then it's going to go with that because there's the statistical likelihood, and then there's that weighting that's applied, that additional constant. It's like there's like metadata against the data through which it uses to make decisions.
Yeah. Again, if there's anyone who's a machine data scientist on this call, don't stother us. But it's a very very first pass approximation. But yeah, the gist of it in this context, a hallucination is just when you ask a question and gives you something that's made up, not based on anything. And the reason why, like, if you go back over here, to this, the reason why you don't see a lot of hallucinations, if at all, is because you can think of it as like not saying what is your name, but like in terms of you can think of it as auto completing. Like, my name is Bob. What is my name, right? Like, well, the auto completion for that would be Bob, right?
Yeah.
Because you've gotten all the relevant data. So you're more likely to have hallucinations when you ask a question where it doesn't have any access to relevant data, where you kind of take this architecture approach where you're feeding in the relevant data and you're gathering live observability data, then you end up seeing very little of that.
Yeah, and it's it is a real quality of life thing, right? To have something that goes through, and the data is all there. The data exists in places that are accessible. Having a privileged system act and go slam all the data together that it knows you need, and interpret that data into information. Just a huge quality of life. I like reading plain text, not sitting there assessing charts and trying to determine, like, okay, there's a huge spike in CPU, but like, what's the scale of that spike? Because if it went from 0 to 5 because I just applied my first workload, right, the scale of that is way different than if I went from 5 to 350, right? That's different. So it's very nice, especially if, when you're responding to alerts, the thing that we talked about this a little bit earlier, like, your context shifting. Whatever you were doing is now irrelevant, and only this matters, only this context matters. And in this particular way, your actual human brain can actually do a little bit of a hallucination as well, because whatever context you may have had before you started working the alert can influence how you're thinking about the current one.
Yeah.
Which is something that I think is such a fun, a little slightly scary, but it's a fun thing, because it actually also can be really helpful. Because if you are seeing something and it happens to be the same as something else you've seen, now you can identify trends.
Yeah.
Right.
Yeah.
But
you're just auto completing too, just on the historical data.
Yeah, exactly.
I want to make sure we get to the open source part, right? I promise I wanted to spend most of the time there. We're already like at the hour.
Whatever, we can keep going. I don't have a hard stop. Johnny might. Quick question for the person in the chat, which was because they joined late. Do you want to, like, kind of 2 sentences re-explain HolmesGPT?
Yeah, so HolmesGPT is an AI assistant that takes alerts like this Prometheus alert, cube job failed, and it automatically gathers up data and then gives an analysis of that alert. Like, here's an investigation, then here's some possible root causes. And in this case, it was a connection issue with Prometheus, right? So it's an AI assistant for solving alerts faster based on your observability data. It's not for answering questions like about Red Hat products, but there is a fantastic OpenShift product or project coming out to do so. Blinking on the name, but you guys know it, right?
Johnny said it, and then I didn't hear it.
No, it's Lightspeed. I think
yeah.
OpenShift or Red Hat Lightspeed, if I'm not mistaken.
Yes.
Yep.
Yeah. So that is the thing you probably want to look at for documentation. And this is actually also the 2 kind of approaches that you see people doing for this sort of thing is the typical sources are we're going to pull in data from documentation. And then the other angle that we focus on more is we're going to pull in data from the observability tools. And then a little bit from organizational sources like Confluence or where you have runbooks and so on.
Yeah. Okay, let's go to the CLI. Let's go to the open source bit. And
okay. Let's go to the fun part.
I preemptively apologize to the viewers that this stream will run long, but also our viewers have frequently asked us to let the stream run long, so you're welcome.
Okay. So let's just go here. I'm running a local version, but normally you just run Holmes, like if you install from Brew or what have you. And I'll just ask a question like, what deployments are not running desired capacity, right? And what this is going to do is it's going to like go off and gather some stuff, running kubectl get deployments. Okay, and here's the answer based on the data I gathered. So maybe let's go and like let's ask like, why is the Redis deployment in the network policy namespace not running? And you can see here the commands it's running. So it's running, okay, kubectl get, fetching like all the deployments, looking for Redis, right? Looking at this deployment, like diving down a little bit deeper into that. Oh, okay, it's going off and it's looking at a persistent volume now. And what's really interesting here, we'll look at the result in another second. What's really interesting is each stage builds upon the things from the previous stages, right? So the Redis deployment isn't running because the persistent volume is unbound, right? And here are some possible solutions. So like this is kind of an example of this chain of events here where you start from the name of the deployment. It probably went off in here and defined this. It looked at a specific pod, then it ran the scribe on that pod, then it looked at the PVC. So the PVC is unbound. So like as it goes along, it's doing this process iteratively.
That's neat. Does this have the option for because I see what tools it runs. Does this have the capability for you to say, okay, and then also like in a temp folder, put the results of your command so that I can go through and see what you saw?
So you can do it here where you could do like show tool output.
Aha.
It's a little bit much sometimes on the CLI. While that runs, I'll just show you. We do surface that up here and showing like the data that was gathered, which is a little bit easier to do in UI format. And we also have an open source version of this for Slack. So like here's an analysis in Slack. And then in Slack, you can see actually all the stuff as an attachment. So this is also pure open source. So like here's a Prometheus alert in Slack. We have it here in alert, like high latency for customer checkout. So like HTTP requests are taking a really long time. There's high latency. Why is that happening, right? And it went off, it ran kubectl logs, or went off, it looked at a specific pod then, looked at some other stuff. And I could see here like all the data that it pulled in that probably wasn't found, right? But one of these was eventually found. And the data that it pulled in from that. And then I could see, oh, this was a database connection timeout. And I'll go back here for a second to Slack. So yeah, like here's the output. You see, I'll describe PVC. Here I can see the output from that. If I go up a little bit, right, here's looking at like the events. So you're looking at the deployment and the events that are related to it, the replica set, and so on in tree view. Here's running that kubectl describe. So you can see what went into making that decision.
Awesome. That's very cool. You're right. The UI thing is very nice because then you can just get individual files.
Yeah. It's the type of thing that's harder to do in the CLI. Not impossible, but it's harder to do in the CLI.
Yeah.
We looked actually, we did an experiment where we used LLMs to summarize the files and to say what was in each one, but the latency ended up being unbearable. So you get like a really cool summary, like it would gather each file and then it would give you like a one-liner on what is actually inside that file, or extract like the most meaningful lines separately. But you end up doing a very large number of calls on that, as opposed to kind of letting it just do its thing and then output the result at the end.
Yeah.
And latency was awful.
So if you have like specific stuff that you're working on, right? Like Hilliary has all of her ARO stuff and stuff like that. I do all the pattern stuff, right? So if I want to train this, right? So like maybe I want something very specific within my framework, or Hilliary wants something very specific within her workflow. Like how do we train this? How do we incorporate those actions into that?
Yeah. So for Prometheus alerts, which we also have an open source version of, then you would give it like custom instructions for that alert. So I would just say here, like when you investigate kube job failed, do X, Y, and Z. And then the other way is to just, we have I don't remember if it's built in or you have to add it on, but we have a curl tool. and like a Confluence tool. So then you would give it as well, like you could say, go and like use like this runbook page or use this page, then go off and do things based on that. And then it will just read that page at the beginning of the investigation and then use what it read from that page as it goes on.
That's dope.
That's pretty cool. So we've got another question in the chat. I'll display it here. So like what level is it now? C days to deploy, image pull issues, job failing can be handled to provide insights, but it is also capable for, let's say, a BGP, got to check my dyslexic self there on these things, pairing config failed, etc.
Yeah. So it all depends on the tools that you give it. Like there's enough literature out that like OpenAI was trained on around BGP pairing and so on. And like there's enough data on the internet or enough pages that you could feed in. What it doesn't have out of the box is it doesn't have the tool to like actually fetch any of that data around BGP pairing or to connect to the router. So the main thing you would look at there is adding on like your own template commands to give it access to the right data.
I think it's an important thing to know because this is interpreting Prometheus metrics, right? That a Prometheus metric can be kind of anything. Right? And it basically is just a way of sort of normalizing data, but you can train it to get just about anything. So an example of this is in OpenShift. Actually, do you have that OpenShift cluster around?
Yeah.
In OpenShift, there's insights. And in insights, there is something called the deployment validation operator. And the deployment validation operator is a Prometheus exporter, and it basically just kind of it runs its checks and it's like, hey, are you running pods with the what the recommendations of like memory limits, for example, and if you don't have memory limits, it'll fire a Prometheus metric that says, hey, you're not doing this thing, you should be doing this thing, and so that is something that like anything can be a Prometheus metric. So when you have an LLM or a GPT, whatever you want to call it, that can interpret Prometheus metrics, keep in mind that Prometheus metrics can be anything you teach Prometheus to normalize. Yeah.
And I mean, here in the command line, we're even just feeding in like plain text questions, right? So we have some integrations even that like take a PagerDuty, take it like as a starting point as well. We have an integration for that, or for taking like it doesn't just even have to be Prometheus alerts. But okay, so I hope we had a chance though to like get into some of the open source aspects as well. I know we're way over time.
Yeah, we are over time. I definitely, I think we all need to get running soon. Last thing before you go though is what's the GitHub repository? Where do we go get HolmesGPT?
Robusta Dev, HolmesGPT, and give it a star. If you like it, you should put a star on it. And we have instructions here, easy to download, easy to get started with. If you want that Slack integration or if you want the UI, then that would just be here on Robusta and robusta.dev. And then you can, we also have a free tier for all of this if you want to get that UI. And that's everything, I guess.
Thank you so much for coming on and demoing this. Thank you so much for putting the things that you do into the open source world. I think everybody really appreciates that. We're going to let you go. We're going to be back here in 2 weeks with the OC Mirror team. I couldn't remember 2 weeks ago which order this was in, but yeah, 2 weeks from now, we'll be back here, same time, same place, different people. We'll have the OC Mirror team on to talk about OC Mirror, which is a really neat little tool. Johnny, get ready to queue up the thing because I'm going to remind people that they need to choose their technical debt wisely, and we will see them in 2 weeks. Bye.
Thank you so much, guys. Take